Okay, moving on. Let's solve 2 cosine squared minus sine x equals 2. We're going to use radians. This is the first time where we notice that our trig functions they give us for one time one is squared, the other one's to the and the other one's to the first, but also just the fact of that they are actually different. We don't have them the same, but I can get them the same. That's what all of our identities are all about. That one identity that I think I'm going to pull from is the fact of sine squared x plus cosine squared x equals 1. So I can replace cosine squared x with 1 minus sine squared x, just moving the sign over here. And then by doing this, or I could, the other way around if I wanted to, I can replace it with sine squared x is equal to 1 minus cosine squared x. Okay, so at this point I really have two options here. I can go with the whole, I can rewrite cosine squared as 1 minus sine squared, or I could rewrite sine squared equals 1 minus cosine squared. And if we go back to our problem, all I have is the only thing that's being squared really is the cosine squared, so I don't really have two options. I can only use this very first one right here, because the only thing that's actually squared is cosine squared. Okay? So this part says, this front term says it's 2 times cosine squared, so I'm going to go 2 times its replacement, which is 1 minus sine squared x. And then I just have that minus sine x equals 2. So finishing this out, we've got 2 minus 2 sine squared x minus sine x is equal to 2. And right here, everything now is in terms of sine, which is great, and realizing that I have a quadratic because one of my sines is being squared. And the only way to solve a quadratic is either factor or complete the square or use a quadratic formula. And like y'all all know already, I like to factor. It's a lot easier, to me at least. Seems like it's a lot less steps. And since this sine squared x term is negative, I want to move everything over here to the right because I want to factor with my front term positive. So if I move that all, I'll start out with 2 sine squared x. The sine x becomes positive when I move it to the right. I've got 2, and if I move over the 2, we actually have 0. So it all equals 0. From here, got 2 terms. They both have sine x in common. So if I factor out sine x, what's left over is 2 sine x plus 1. And just double check, sine x times sine x is sine squared. Sine x times 1 is sine x. Got 2 products, or a product of 2 terms equal to 0, so let's set each part equal to 0. Okay, this first one's done. We're ready to get an answer there. This next one, I need to move the 1 over, so it becomes negative 1, then divide off the coefficient, and we look at negative 1/2. Okay, so first one says, when are my y values equal to 0? The second one says, when are my y values equal to negative 1/2? And y's are negative in quadrants 3 and quadrants 4. Alright, it asks us for our answers in radians, so let's get started here. Let's go with the easy one, the first one. When are my y values equal to 0? Well, y values are 0 when you have no height, so you're on the actual x-axis, and so that would be either at, we'll consider that, if you want to write it as 0 pi, we can say that, and then also at pi. And sometimes we include 2 pi as well. It depends on if they want to do a full circle or not. Okay? And then the next time is we want to know, when are my y values equal to negative 1/2? Well, thinking back to quadrant 1, the first time I have a y value of 1/2 is at pi over 6. So pi over 6 relates in quadrant 3 as 7 pi over 6, and in quadrant 4 as 11 pi over 6. So there are my answers. The only one I got to check on real quick is that 2 pi to make sure. If it's in there, I mean, honestly, I won't not count it wrong if y'all list it, because it's like, do you consider from here all the way around and give all the answers within one full circle? Or because 0 and 2 pi are technically the same thing, it really doesn't matter to me. Okay, example 6. We want to solve, when does cosine of 2y equal 0 using radians? Okay. This is what's happening first for the first time you'll have ever seen before, is instead of having a number out front, my number is attached to my angle. And I want to give you guys a heads up. You can never, ever, ever divide off that number attached to your angle because it actually means something. And as if y'all saw in your notes, what it means is how many rotations am I going to give my answer. So what this is saying are when are my x values equal to 0 for 2 full rotations. That's what that problem says. When it says cosine of 2y equals 0, as it says when does my x values equal 0 for 2 full rotations. Okay, so what we're going to do is start with our angle. Our angle is 2y. It's not just y, it's 2y. And then for 2 full rotations, I want to list out in radians when I have x values of 0. Well, that's going to be right there along that y-axis. So the first time is at pi over 2. The second time is at 3 pi over 2. And then we have 5 pi over 2 and 7 pi over 2. So the first pairing is in that first rotation. The second pairing is in the second rotation. Okay, and then to finish this problem out, we just want our answer in terms of y equals, not 2y equals. So we divide this left side by 2 and divide everything over here on the right by 2. Let me show you this. If I take pi over 2 and I divide by 2, it's the same thing as saying pi over 2 times 1/2, and that gives me pi over 4. So in a nutshell, when you're dividing by a whole number like 2, you're just multiplying it to the denominators. So it's going to be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And there is actually my answer that I'm looking for. Okay, so let me go back through this just one more time. Whatever angle they're asking you to solve for, that's what you're going to first start out with your listing. Notice I listed it as 2y. I didn't list it as just single y's. And then you're going to go for however, if that was a 3, then I would go for 3 rotations. So I would have 3 pairings, or a total of 6 in this list. Okay? And then from there, just divide off that number attached to your variable, and you can call it done. So example 7. I want to solve when does tangent of 3y equal negative square root of 3. Okay, so tangent. A lot of the times what I do, because I don't have the tangents memorized like I do with the sine and the cosine, is I write out my 2 options. I can either go with that option, which square root of 3 over 2, that's at 30 degrees. Or at 60 degrees, I can go with 1/2 square root of 3 over 2. Okay, so tangent is y divided by x, or y times the reciprocal of x. Here would be y times the reciprocal of x. So which one of these pairings is going to give me the square root of 3 is an answer. If I cancel off here, it looks like it's going to be this one right here. So we're really interested with the 60-degree one. Okay, but because my answer is negative, then obviously what I'm looking at is for 3 rotations. I'm going to give each of my answers where tangent's negative, which is in quadrants 2 and quadrant 4. Alright, so here we go. 3y is equal to, in the first rotation, my 60 degrees, what it relates to in quadrant 2 is 120 degrees. And then in quadrant 4, it's going to be 300 degrees. Okay? Now the easiest way to get, here's first rotation, is if I take this first answer, and to get a coterminal angle to this, you just add on 360. So 120 plus 360 is 480. And then 300 plus 360 is 660. And there is technically my second rotation. And then to get my third rotation, I'm going to start with the second pairings, and I'm going to keep adding 360 and 360. So 480 plus 360 looks like 840. Let's see, 4, 5, 6, 7, 80, yeah, 840. And then the other one looks like it's going to be 1020. And there's the third rotation. If this asks for this into radians, all I would do is keep adding 2 pi, 2 pi, 2 pi, and 2 pi. Okay? And to finish this up, all we have to do is to go through and divide all of these through by 3. So really, y is equal to 120 divided by 3, which is 40. 300 divided by 3, which is 100. 480 divided by 3, which is 160. 660 divided by 3, which is 220. 840 divided by 3, which is 280, and 1020 divided by 3, which is 340 degrees. Okay, and if you really want to kind of a way to quote unquote check your answer, is if by the time you're done, if all of this, what's listed here, is in one rotation, one full revolution, so between 0 and 360, you know you've gotten your answer, and that's what it is. All right.